we review conservation of energy problems, the mechanical energy is conserved. The mechanical energy is the sum of the kinetic energy plus the potential energy, and the theorem says that the total mechanical energy at the point A is equal to the total mechanical energy at the point V. Working with this, you will find that E sub Ki plus E sub Py, our initial kinetic plus potential energy initial equal kinetic plus potential energy final. This is what we have done, and is to solve problems. So this is the summary. The summary is that if the force is minus Kx, the potential energy will have Kx squared. If the force is away, the potential energy is mgy. What we want? Okay, we want to solve this problem. In this problem, say you have a spring, the K of the spring is not the kinetic energy, it's the K, is the Newton per meter, is 10 to the 3. The mass is 1 kilogram, and you compress the spring 7 by 10 to the minus 2 meters. And it say you release the spring from here. What is the height? So how you will do? You will say, this is my point A, and this is my point B. So mechanical energy at the point A, mechanical energy equal mechanical energy at the point V. At the point A, what is the mechanical energy? Kinetic energy plus potential energy plus elastic energy of the spring. The spring is compressed a certain amount, equal at the point V. What is kinetic energy plus potential energy plus the spring, if there is a spring at the point V. But at the point V there is no spring, so there is no elastic energy of the spring. So let's go to solve it. Find the height, find the HV. So this is 0, the elastic potential energy at the point V. Kinetic energy at the point A, 0. Potential energy at the point A, 0. It goes from the 0 because we have chosen the floor like this, so the 0, the height of the mass is 0. Plus elastic potential energy. Yes, it has 1/2 K, the compression square, equal. Kinetic energy at the point V, 0. Potential energy at the point B, mg HV, plus 0. So the equation will say 1/2 Kx squared equal mg HV. Oh, they look for the HV. The HV will be 1/2 Kx squared. The K is the K, the constant of the spring, divided by mg. So let's go to plug-in number. The maximum height that can arrive at the maximum height, the velocity v sub v is 0. That's why I said that the kinetic energy is 0. This is the maximum height. At the maximum height, the height hv will be k is 10 to the 3, the mass is 1 kilogram, delta x is 7 by 10 to the minus 2. K is 10 to the 3. So 10 to the 3, x squared will be, the compression will be 7 by 10 to the minus 2, 7 by 10 to the minus 2 squared, divided by the mass is 1 kilogram, by g is 10. So the hb, this spring, the k of the spring, hb will be, the 10 will cancel with 10 cubed, so it will be 1/2, 100, 7 by 7 is 49, 10 to the minus 2 is 10 to the minus 4, so it will be 1/2, 10 to the 2 by 10 to the minus 4 by 49, so the hb will be 1/2, 10 to the minus 2, so it's 10 to the minus 2 is 1 over 100, so it will be 1 over 249. So it will be 50, more or less, like 200. So it will be 5 divided by 20. So the height will be, if I divide by 5, 20 divided by 5 is 4, 1 meters, so 0.20 meters. The new height will be 1/4 meters, 0.25 meters is the height that he can goes up, is HB. HB is 0.25 meters, and the problem is solved. Let's see another problem. Find the maximum elongation. So you do the same thing. This is the point A, and this is the point B. Assuming that here there is energy. What is the energy that it has? Kinetic energy plus potential energy, so HA, VH, plus compression, XA. So the problem is not well defined because this is the equilibrium, this is the point, this is the position of equilibrium. It doesn't say, I should have written that the velocity V at A, at the point A, is some velocity VA. So let's go to do it. So what it says, the principle of conservation of energy, that the point V is here. I said that this is the point V. So the point V is here, the point A is here. So it has velocity V. It has velocity going in some direction. I don't care in what direction. It may be going up or going down. It has kinetic energy. It has potential energy. It has elastic energy. And this is equal between 2 points. It has to be conserved. mvv squared plus mghb plus 1/2 k by the elongation of the position. So let's go to do the problem now and to put numbers. So this is the mass, this is the x equals 0, let's say. So this is x equal is compression, is x equal, let's say, so this is the floor, this is YA, this is YV, and this is the compression. Let's say what the problem is asking, find the maximum elongation, find the compression, I don't know what I said, the elongation. Find YV, this is what you should find. And finding YV, you can find what is the compression. So at the point A, you have some amount of energy. Let's say that VA is 10 meters per second. Let's say that the K is 1 newtons per meter. So at the point A, you have kinetic energy. And let's say that the mass is 1 kilogram. So at the point A, you have kinetic energy. How much? 1/2 the mass by the velocity square, 10 squared. You have this amount of joules at the position A. At the position A, you have mgha. Let's go to choose the floor here on this level. On this level, it's better to choose the floor. So at the point A, the potential energy is 0 because I can choose the floor at anyone. At the point A, this is the point A of the equilibrium position. There is no potential energy stored because the spring is not a stretch. So this is only kinetic energy what I have at the point A. Equal the kinetic energy at the point V will be 0 at the maximum elongation, plus mg hb. But hb now will be this distance. Oh, this distance, HB, because I have chosen the floor here. So HB will be this distance, mghb, plus 1/2 k by the elongation square. The elongation square will be HB squared. So what it asks me is, what is HB? So in this problem, I have the total energy is, at the point A, is kinetic energy. Potential energy is 0 because I have chosen the floor to be here. Elastic potential energy is 0 because there is no compression of the spring. And when the body goes in this direction with certain velocity, 10 meters per second, the spring will be compressed. I want to find this compression, the x. The x is the hp also. So the potential energy will be mghb, and the compression will be hb squared. Xv will be the compression square. So the problem is already solved. So here I have 50 joules. 10 squared is 100, divided by 2 is 50 joules. 50 joules of energy is mghb. M is 1 kilogram, G is 10, HB I don't know, plus 1/2 of K, 1/2, and HB squared. So what I have now is an equation that is a quadratic equation, and I have to solve it for HB. So I multiply by 2 the equation, and I have this equation. So I can solve it. So I can solve using the discriminant. And how it will be the HB? That will be the elongation, will be square root. HB, this is a quadratic equation, square is minus b, minus 20, plus minus square root of the v squared 20 squared, plus 4ac, plus 400, or minus 4ac, with this minus will be positive 400 divided by 2. So HB will be equal minus 20 plus minus. I will choose the positive one because the negative one will produce a negative height. I'm going to the compression, so I will choose the positive. 400 is 800. A square root of 800 divided by 2 will be minus 20 plus the square root of 800 should be something like, let me calculate quickly. 800 square root is 30 by 30 is 900, so it should be like 25. 25, let's say that the square root of 800 is 25. Divide by 2, so it will be plus 5 divided by 2, so the height will be 2.5 meters. 2.5 meters will go up. This is the HB, and the compression of the spring is also 2.5 meters. Okay, because we have chosen in this way. Okay, there is another problem. See this thing. So that's all. Okay. Okay, that's